Awesome. Very good, good day indeed, and welcome. Hello, my name is Ruben. As Michelle mentioned, I'm a field CTO of Atlantis Computing. It's really a pleasure and honor to host this event together with Jason, and to educate you and others in the field about Atlantis and NVIDIA, and why this great combination is valuable for you. Jason, can you briefly introduce yourself?
Sure. Good afternoon, good morning, good evening everyone. I'm Jason Sutherland, Senior Solutions Architect for NVIDIA. For those of you that don't know me, I've been around the virtualization world since the late 1990s. So this kind of architectural planning and these kind of discussions are in my blood. So I'm looking forward to this this next hour.
Awesome. Well, I'm active in the application remoting and desktop remoting space for a while, as you as well, Jason. Yeah. Great to have you in this webinar. So the 3 session objectives for this hour, and as Michelle mentioned earlier, when you have questions, use the questions option in GoToMeeting or the chat option in GoToMeeting. We'll try to answer them through the webinar, but we'll definitely have time at the end to try to answer your questions, or reach out to us via email or social media if you have questions as well. 3 session objectives for this session is understand to make virtual workspace faster, simpler and cheaper. I think these are the 3 main challenges today of virtual workspace, both VDI and virtual workstation. Second one is understand, and Jason will lead in that segment, understand how graphics performance can be drastically improved by adding NVIDIA, which is beneficial for all your business consumers, for all your end users. And also understand the combination, the impact Atlantis and NVIDIA has in your virtual workspace. So it's make virtual workspace faster, simpler and cheaper, graphics performance, and the combination of NVIDIA and Atlantis. These are the 3 session objectives. I briefly touched on this in the session objectives. I think when I look at the historical challenges of virtual workspace, one of them is complexity. Feedback is it's too complex to design, build and maintain. The other one is cost, and storage is a large component of this challenge. It's not cost efficient, both CAPEX and OPEX, operational and capital challenges there. Performance, both end user experience and admin experience is poor or perceived poor. And the 4th one is protection. It's hard and quite often too expensive to integrate it in your disaster recovery plan. These are 4 major challenges I see, and I spent quite some time, quote, quite some time in this desktop virtualization space. This is what I see, and I know for sure Jason and I, we met each other quite often at events and user groups. And when we talk about these challenges, these are the challenges we both see.
That's right. It's always the same things that come up over and over again.
Solve complexity, solve cost, solve performance are the 3 major topics, and also integrate this in your DR plan as an interesting one. So everyone wants an awesome user experience. Everyone has that in the mind. Why? Because this is the perception. This is the baseline. The baseline for the majority of people, for me as well, is my MacBook Air or is my Ultrabook. This is the baseline. And an Ultrabook or a MacBook Air, as an example, have 2 things which drives a great user experience. Is a GPU and is flash. The reality is when we design, build and maintain desktop virtualization solutions, reality is that we forget about GPUs and storage quite often. And the reality is that this is the reality or perception of our business consumers using our solutions to get apps up and running. Poor user experience. It takes too long to boot machines or to recompile machines from an IT perspective. Long log on times. Slow application start and launch times. Disabling search as an example. Disabling search is dramatic for me. It is dramatic. I use search on a daily basis, probably you Jason, as well. Without search, it's really tough to get stuff done. As a simple example, so disabling search is, for me, is a poor user experience. And quite often search is disabled because it is a serious and huge impact from a storage perspective. So how do you solve these type of things? We'll try to answer that question to solve these four major challenges: complex, cost, and user experience. But before we do that, we'll spend a little bit of time in the virtual workspace use cases. I think it's important to understand the use cases. And you will see in a couple of slides that it's not only about high-end graphics or designer or the workstation type of user in this arena. I try to explain this with this slide: virtual workstation versus virtual desktop. And I don't believe it's like versus, but there are use cases for workstation and there are use cases for desktop, as I explain in this slide. So in the virtual desktop space, the audience or the target audience is much more a task or knowledge worker, using Office, CRM, ERP, unified communication type of applications. Browsers, don't forget these type of applications. Basic computer resources. I think 1 to 4 gig of RAM, like 256 gig of SSD, Core i5, Core i7 type of machine, in a range of $700 or euros, $1,500 or euros range in pricing. This is my type of machine. I'm using a Lenovo machine. It's an X1 Carbon. It's up in the 1500 range or even more. 4 gigs of RAM, Core i7, 512 gigs of SSD. That's my machine, and I'm suited in the virtual workspace, virtual desktop space as well. When we look at the virtual workstation, it's power users and designers, 2D, 3D graphics, CAD, PLM, BIM type of scenarios, high-end compute resources, lots of RAM, multiprocessor Xeons, multiple SSD, PCIe flash, NVIDIA Quadros is what I see quite often. M60 is the like the Ferrari on the NVIDIA GPUs. And range, well, you can make it extreme, like $10,000, 10K is possible. I've seen customers using this type of workstations in field, not for one or two users, but hundreds of users in this space. Why this differentiation? Because a lot of attention in the GPU and quote-unquote VDI space, it's heading towards virtual workstation. But I think everyone is benefiting and has benefit from using GPUs also for the VDI space, for the task and knowledge workers. Why? Because, as I explained earlier, the baseline is my Ultrabook, and this Ultrabook has a GPU, and the application I'm using, like Office and browsers, as an example, are leveraging a GPU. And when I don't have a GPU in my virtual desktop or my virtual workstation, that will have dramatic impact in my user experience. And as we discovered earlier, user experience is one of the challenges or historical challenges in the virtual desktop and virtual workstation space. So when we combine virtual workstation plus virtual desktop, that's when we get virtual workspace. So virtual workspace, the workspace is the combination of workstation and desktop. And it's good to differentiate these two and also understand the use cases for both desktop and workstation. This is an interesting question, and I'm sure that Jason can answer these type of questions. What are the key user categories, as an example?
Yeah, that's right. I mean, there are, and I think the points that you've just made, Ruben, are really relevant, is that there are effectively two different tiers of workstation types. There's the standard desktop and then the powerful workstation. But quite often our historical experience with virtualization has been in the desktop space, and we've always built environments around that. And we know those use cases and user categories well. But when it comes to the virtual workstation, and that higher end and more performant or more demanding of user types, that's when those categories become a little different. And so if we look at a spread over a pyramid, or a triangle I should say, that you've probably seen us use several times in the past, we have right at the top of this triangle the designers, the very demanding users who are going to run very, very resource intensive applications. Now, there are only going to be a few of those, or relatively few of those in an organization. And then beneath them will be the power users. And it's in the power user range that we tend to see this blurring of the line between virtual workstation and the virtual desktop, and also virtual apps as well. So when we talk about virtual desktops and apps, we're also thinking about RDSH and XenApp type workloads, as well as people having a dedicated desktop. So don't eliminate them from potentially graphical use cases. So we have this tier broken down, and what we're trying to do here is just show that in simple terms you can look at the very top of this triangle as being required as users that require a virtual workstation, and then as we move further down we move away from the workstation and into desktops, and as we move to the bottom quite often we see just virtual applications being delivered, maybe just one or two critical applications being delivered, but still each one of them is going to benefit in one form or another from graphical acceleration. If we look at the different use case types, these are the ones that we tend to default to and tend to jump to when we think about GPUs and graphics acceleration. So construction design, oil and gas, geoscientific analysis, those kinds of things. Designing of aircraft or vehicles and engines, and looking at medical imaging or creating content and creating material within film and media. And because of that we start to think in the terms of very specific application types. So if you look at the applications here, these are the ones that you automatically look at and go, they're going to need a GPU. Every one of those there is a graphically intense and a graphically demanding application, and 4 or 5 years ago we would have said we can't put these in a virtual environment. And today we know that we have the GPU available to us and we can take that forward. But what we overlook very frequently is what underpins these applications is an operating system. And operating systems, particularly Windows, are becoming more and more graphically demanding and more visually intensive. So they expect to see hardware acceleration there, and to get the very best user experience, certainly from Windows 8 and Windows 10, they're written to take advantage of graphics and hardware acceleration. So without a GPU in there, the user experience becomes degraded. They lose the benefits of a lot of the visual functionality that they get there.
Yeah.
But also,
Jason, and just jumping in briefly, so we highlight GPU obvious in this webinar, but what I see as well is that it's not only the GPU, but it's the full package. The CPU, the amount of cores, the clock speed, the storage, all these type of things are combined. Well, has direct impact in user experience, and the GPU is an important part, but like the CPU characteristics, as I mentioned earlier, is another example, and storage obvious is another example, which has serious impact in the user experience for high-end applications as well.
Yeah, it's absolutely critical, because I think what we have seen in the past is people just presume that because you put a GPU in, they don't need as powerful a CPU, and actually these applications also expect a lot of CPU power to be available to them, and certainly in very high clock speeds in many cases. We also see the CPU being very important when it comes to the protocols itself. So how do you access this? It's great having a virtual desktop that runs very fast, but you've still got to get that user experience down to the user. So whilst we're only talking particularly about GPU and storage today, really think about the CPU and the rest of the environment as well as having an impact on that end user experience and making it work well. When you look at the GPU options that are available, there are a number of different ways of delivering graphical acceleration or hardware acceleration to the user, from direct mapping, one-to-one relationship with the GPU, to using the CPU to emulate it, through to sharing options, whether it be true GPU virtualization like vGPU from NVIDIA Grid, or giving a shared GPU technology such as VMware's VSGA, which again runs on top of and takes advantage of the Grid GPU, but isn't giving you that direct access to the GPU, the hardware itself. So lots of different options dependent on the requirements that you'll have in your use case. So if we come back to these different, this pyramid and take a look here, you can see that we can potentially break these down into, the designer at the top end is going to have a GPU dedicated to them. So that's a one-to-one relationship with that. It could be GPU pass-through, or it could be a one-to-one virtual GPU. And then as we move down, we get into the realms of shared GPU, API interception. So this is the ability to use software to share the graphics hardware, such as VMware's VSGA and Microsoft's RemoteFX. And then as we come back down to the bottom, we see a lot more software rendered graphics. But what I'll talk about later is now the ability to have GPU acceleration easily and relatively inexpensively available to all of these users down at the lower tier by delivering it through virtual applications. To give some rough idea of the proportion or the ratios of people that fit into this, you're looking at about 25 million, roughly speaking, designers compared to 400 million in the knowledge worker space. So you can see that when you look at this, the predominant focus today, from the way that the GPUs are being shared, all of the performance goes to the designer. But there are still solutions and technologies out there with grid sitting underneath it that can deliver across the stack to those knowledge workers as well. And again, we'll talk a little bit more about potential options later. But now we have a poll, and so I'll hand over to taking the poll now.
So the question is, are you considering using GPU in your virtual workspace? And I think, Michelle, when you can launch the poll, that would be great, so people can answer this question. See if it works. Good. Michelle, can you share the results as well?
There we go.
Pretty interesting, right?
It's very interesting. It's interesting to see that 27% already are using GPU in one form or another.
Yeah.
And we've got another 24 within 6 months.
So almost half of them is using it or will use it in 6 months, and like 40% don't have plans yet. Maybe great reasons, or maybe maybe this webinar is helpful to educate and understand. I'm also interested if you're one of the guys or girls who don't have plans. I'm interested. Why not? Is it use case, or is it like price, the impact, the extra cost for adding GPUs? Well, it's maybe you can add some feedback in the chat or questions window. Can be helpful for us at the end, or we can use it anyway.
Yeah, potentially we'll be able to use that to answer some people's questions as we go.
Yeah, good topic. Let's see. Let's move on and proceed with this one. Double checking. You see the slide, right? How to solve virtual workspace challenges, Jason. Is correct?
Yes, I do.
Okay, awesome. So that's the topic. We talked about the challenges, 4 challenges. We talked about use cases. Question is, how do we solve the workspace challenges? We know the use cases, we know the challenges, how to solve them. I truly believe, and this is one of my missions, my personal missions, and my missions also within Atlantis, is that the biggest competitor is not Citrix versus VMware. It is the physical PC, and the goal of like NVIDIA, Atlantis, the industry, the vendors, the competitors as well, is to make the virtual workspace better, cheaper, and faster than a PC. And with PC, I mean desktop and workstation combination. So the biggest competitor is the physical PC. And solving these 4 challenges will help us to make the virtual workspace better, cheaper, and faster than a PC. And I don't care if it's really cheaper than a PC, because there are a ton of other benefits of a virtual workspace. But it should be inline, better, cheaper, faster than a PC. How do we solve these historical challenges? How do we solve complexity? I truly believe in an appliance, which can be a software appliance or a hyperconverged appliance as well. I believe in software-defined storage, where the intelligence of storage is in software, where it's linear scaling and building blocks for workspace and data center. So hyperconvergence of compute and storage and virtualization and networking, when you merge these segments together, that will solve complexity or makes it much easier to deliver and to deploy desktop virtualization or virtual workspace. Solving cost, as I mentioned earlier, storage is a large portion of the cost involved in desktop virtualization. Solving cost by using commodity hardware, no SAN, and software distributed storage platform. I believe in intelligent storage software. That's why I joined Atlantis as well. I truly believe in advanced data services such as inline, in-memory deduplication as one of the key data services. There are ton of other data services, but this is an important one. And as I mentioned earlier, merging storage, compute, and networking was also solving costs because it becomes simpler and easier to maintain. And I believe in a programmable infrastructure. So REST API and PowerShell is a core asset in creating a programmable infrastructure. And hyperconvergence and software-defined solutions and software-defined storage is a key asset in the programmable infrastructure, which is helpful in solving costs as well. Not only CAPEX, but also and especially OPEX in the context of programmable infrastructure. And solving performance, making sure that the end user experience is awesome. User experience is king. By leveraging flash, by leveraging memory, in the near future by leveraging 3D XPoint as an example, and adding intelligent software to this stack, and deduplication not only from a cost perspective but also from a performance perspective is very beneficial here. And with that, enable search as an example. Also GPU and the development of remoting protocols is very helpful and key in solving the performance, user experience and admin experience as well. So solve complexity, solve cost, solve performance, GPU, remoting protocols, flash, solid state, software-defined storage and hyperconvergence are core assets in solving these VDI challenges. And these solutions are available today. So there's no reason that complex cost and performance are still like the discussion points today. The question is, how do you solve it? By applying these technologies as I mentioned earlier.
Yeah, so I think just to add to that, Ruben,
sure.
People today should not be getting a poor user experience in a virtual environment, and that should not be a reason for a project to stop anymore.
Yeah, exactly. Well, we both know, we both are active in the technology field as well. We both know that the user experience is a large chain of stuff, right? It's networking, it's endpoint, it's sizing, it's secure access. There's a ton of stuff in what is impacting the user experience. But when you look at the VDI's part, that should not be a discussion at all today in 2016 at all. So with redefining VDI is convergence, hyperconvergence in this context, and network compute, also virtualization and storage are converged, are merged in like one appliance, which can be a physical appliance or can be software as well. I believe that today we live in the VDI 3.0 days, and that means that, as Jason mentioned, user experience check is solved, graphics check is possible, storage from a performance perspective and from a cost perspective check should not be a conversation at all. Licensing, for instance, from a Microsoft perspective, is partly fixed. I will address that one in the upcoming slide, but it's much easier than a couple of years ago. Complexity with hyperconvergence is fixed, and we look at an Atlantis reference architecture. CAPEX, so the infrastructure cost for a VM is $128 per VM. And always look at the context. When I talk about price, always look at what's the context of that price. So you can check out the context when you download the deck or when you see the recording, which is one of the questions. Is it being recorded? Yes. So you can listen into the recording. But download the reference architecture so you see what the price tag is, $120 per VM, and what's included in that. It's server, it's storage, it's a distributed storage platform as an example. This is available today. Moving forward towards 2020, I call it VDI 4.0, where more competition is being added in the GPU space, which is a good thing. For the industry as a whole, I think it's a very good thing. And also for NVIDIA, it's a good thing to keep NVIDIA sharp, to be honest. Sometimes CPU and GPU combined can be an option. GPU is more commonly available in different types of servers as an example. The connection broker, the VDI connection broker, will be or can be delivered on-premises or in the cloud. The infrastructure on-premises, hybrid and cloud. Look at the developments on Citrix Workspace Cloud as an example, or on the VMware side, or on the WorkSpot side as an example. You can clearly see that the infrastructure is also delivered as a service. Hopefully licensing, Microsoft licensing is fixed, so service providers can benefit from that. And when you look at Intel Moore's law, when you look at developments on Flash, when you look at more competition in the GPU space, all these things will drive costs lower or down. Is the expectation to VDI 4.0 in 2020. I believe that user experience is king, and GPU capabilities and blazing fast solid state is the standard for a modern virtual workspace. As I mentioned, I think twice already, the baseline is the physical machine on my desk, on this desk right now. And that's the baseline. That has a GPU and has blazing fast solid state. So if we see the benefits of virtual workspace, start with GPU and solid state in your design. Or when you already have VDI and the user experience is so-so, keep in mind what the impact is of GPU and solid state storage, like Flash and solid software-defined storage as a great example there. Michelle, can you start this poll, please? So the question is, are you using solid state Flash technology for your virtual workspace today? So yes, already in place. All Flash, yes, already in place. Hybrid, so spinning drives and Flash drives. No, not yet. Not applicable means there are a couple of other options as well. We'll wait a couple of seconds before we close the poll. So 4 options are using solid state technology for virtual workspace. Michelle, yeah, let's see if you can show the results to the audience. Let's see if I can see that as well. Jason, do you see the results? I think it.
I do see the results. Okay. Yeah.
It's 25% is using all Flash, which can be an all Flash array or local Flash. There are tons of details in this question, but it's like all Flash. 43% is using hybrid. 43%, interesting, is not yet, and 6% is not applicable, using other type of solutions. So interesting is that, well, quote, just 25% is using all Flash, which is what I see as well. The challenge is all Flash today is that it's too expensive and quite often targeted for certain use cases, which can be VDI, or can be like a business critical application which benefits from high performance storage as well. So the goal, the vision of Atlantis is to to use Flash for every application for half the price of spinning drive by leveraging intelligent software and applying intelligent software to commodity hardware, both server and storage hardware. And with that, making sure that more and more people can benefit from all Flash performance for every workload. So we addressed the challenges. We talked about the use cases. We talked about to solve these challenges: hyperconvergence, software-defined storage, appliances, software appliances, GPU, Flash are all set in solving these challenges. I think it's the right time right now to move on to the NVIDIA segment, where Jason can explain the evolution of enterprise computing, the impact NVIDIA has in the virtual workspace.
Yeah, thanks, Ruben. So yeah, let's take a look into Grid itself and Grid specifically. So we have been seeing over my time in technology, and I think everybody's time in technology, enterprise computing continues to evolve. And the point that we've got to now is centralization of data, but distribution of the individuals and the people that are working. Mobility has really taken hold in probably less than 10 years. I think that many of us can look back and remember the time before the iPhone and the iPad and devices like that, but none of us would want to go back to working that way. And so having that flexibility and that mobility and to be able to move, but still collaborate with our peers, has really shaped the way that we develop IT solutions and deploy our technologies today. And certain industries are catching up, whereas other industries have really taken this forward and run with it and gone forward and implemented this for a number of their users and number of organizations in that space. So we're seeing this constant evolution. And virtualization is driving a huge amount of this. There we go. Virtualization is driving a huge amount of this. And with the arrival of Grid 3 years ago, we got to the point where we could really virtualize pretty much every single workload that was now going to be on the desktop and deliver the right level of performance, the right amount of performance and power to those users regardless of what they're doing. And that could be anything from, as you can see, there's a command room and control room on a warship there, through construction sites, through to students working in university. Deliver the right experience, the right workload, the right performance to that user. It sounds easy, and I'm sure, compared to where we were 5 years ago, it is easy, but it still needs some consideration and understanding of how we're going to deliver this and how we do deliver this.
Yeah.
As Ruben has mentioned before, every device that we use, every device we pick up, has graphics acceleration, has hardware acceleration in it at some point. So why on earth would we not put that into our virtual environment to make sure that the applications and the user experience that we expect gets the power that we need? So this is where Grid came in, and this is what Grid was developed for, to allow the virtualization of a GPU and the delivery of GPU performance and hardware acceleration inside a virtual machine that appeared exactly in the same way to the applications as it would on the desktop. If we look quickly at how does NVIDIA Grid work, if we look at a very basic block diagram, we have our server with the CPUs in it. Across the top of that, in the virtualization layer, we have our hypervisor, and then the virtual desktops are running on the hypervisor. So the hypervisor is managing all of the resources and the resource access to CPUs, to memory, to storage, and everything that's in there, and our virtual desktops are there. We then implement vGPU, the NVIDIA Grid technology, into the hypervisor. Now that vGPU manager that you see there in the hypervisor layer, that's simply acting as a broker between the driver sitting in the virtual machine, whether that be a virtual PC or a virtual workstation. As Ruben's described earlier on, we have two real different use cases and two real different scenarios, but vGPU supports both. So we can have a virtual PC and a virtual workstation in there. It will have its graphics driver in there, and once it's gone past the broker to determine how to communicate to that hardware, it speaks directly to it. So it gives the absolute best performance that you can possibly get by giving direct access from inside that virtual PC or inside that virtual workstation and getting right down into that GPU. So as far as the applications that are running inside these sessions are concerned, it just recognizes the same driver as it would see on a physical desktop or in a laptop. Now you'll notice here that we have NVIDIA graphics driver, and then we also have NVIDIA Quadro driver.
Jason, can I jump in just briefly? Just one slide back. When you look at the H.264 encoder, yes, on the bottom side, I think it's good to mention as well that like more and more endpoints have an H.264 decoder as well, and therefore the CPU on the server side is being offloaded a little bit, or maybe not a little bit, from NVIDIA perspective, to offload the remoting protocol activities by NVIDIA, so, and therefore free up some CPU cycles as well, while leveraging the H.264 encoder.
That's actually a really good point, and a couple of good examples of that. I think if we look on the Citrix side, Citrix released their last Linux VDA, had the ability to use that GPU that's in the server to encode for the HDX 3D protocol. So instead of using the CPU to do all the encoding, it could use the GPU, which means there's more CPU available to the applications, or potentially more users on the server as well. VMware, in their Horizon 7 release, they included the ability to use the GPU for hardware encoding in their Blast Extreme protocol. And we've seen the ability to potentially increase the user density on a server by using that by up to 20%, because it releases more CPU and makes those CPUs available to more virtual machines or the applications that are running. And we know that Citrix and a number of other protocol vendors are working on taking that further and taking advantage of that to free up CPU resources and to just make things more efficient in the virtual machine.
And also from a latency perspective, lower latency means even better user experience. And with this, latency becomes lower as well. And with that, even better user experience.
That's right, yes, because it takes it stops passing the information back and forth between the CPU and the GPU, keeps as much as possible in the GPU, so we can eliminate that time of sending data between two different processing units. And we've seen some substantial reductions, 50 milliseconds in some cases. Try finding somewhere else that you can take 50 milliseconds out of your round trip time, and it's quite a big impact that you can make on there. Yep. If we take a look at GPU virtualization as well, what we're doing by moving the GPU into the data center is taking advantage of the unused cycles. So if you're on a laptop or on a workstation, you could be out to lunch, in a meeting, not in an office, sitting there and looking at data but thinking about what it is that I'm looking at, or just reading text. You're not actually doing very much with the GPU, if anything at all. And just yesterday I was talking to one organization, and they were in the situation where, based on their analysis, the GPUs in their workstation were idle 70 to 80% of the time. Yet they have to have them there because when they're needed, they need that performance and they need that power for those applications and those use cases. So by consolidating everything into the data center, by moving to a virtual infrastructure, they're going to benefit from having much better utilization of their resources that they've invested in. The GPU itself and the GPU sharing technology, the virtualization technology in there, uses a time sharing method, which means that when people aren't using resources, they're made available to other people. And very much like for those on the webinar that are familiar with things like RDSH and Citrix XenApp, in the CPU fair sharing model, whereby if you are using a resource, you're guaranteed a minimum amount, you effectively get a minimum amount, but if there's more available because other users aren't using it, then you can have that too, until such time as every user comes back on, and then it all evens out and settles down. So it's a much more efficient use of the hardware. Now I mentioned Quadro before as well. Now Quadro is the choice for professional workloads. So this is about adding a lot of acceleration, a lot of performance enhancements to specific applications. And a lot of technology vendors and a lot of application vendors take advantage of Quadro functionality and tune their applications to take advantage of it. And that's why you'll see that Quadro has about 80% of the professional workstation share. All of this functionality is available in a virtual desktop. The applications, or the driver I should say, our driver, which sits inside that virtual machine, will recognize the applications that are running and will dynamically optimize itself based on the configurations and the settings that are provided by the ISV. It's quick, it's simple, and it just works for those users and those applications. The benefits they get from Quadro are realistic models. In many cases, some substantial boosts in performance for those applications, but also certification. So the applications are certified by the ISV to be Quadro certified. And that means that when you move to virtualization, the same applications will be certified in a virtual environment as they are in a physical environment. And you can go and check and see which applications are certified. Very quickly we run a centralized list of these, or the ISV, the application vendor, will also provide that information as well. But also improving productivity. So one of the features that we don't talk about enough is something called NVIEW. And this allows you to have multiple desktops or multiple virtual displays, let's call it that, inside a virtual environment. So even if I'm only connecting to from a device which has one physical display attached to it, in my environment I could have 4, 5, 6, 7, 8 virtual monitors in there that I could have different application workload and different workloads running on and move around. And it means that I move away from a cluttered working environment to a much more clean and tidy environment, so that I can have particular workflows and particular virtual desktops. I shouldn't call them virtual desktops, virtual displays. So it's something that many can take advantage of. If I'm going to move quickly through this, because I think we all know about the benefits of, for the user, they get much better performance, their flexibility, and so when we become flexible, our productivity goes up. Give people the freedom to choose the way that they work, and they will work better and faster and harder. Whereas centralizing things and making things more secure is an ongoing benefit that we've all experienced from virtualization in other areas anyway. A couple of examples of customers that have taken this technology on and taken a proof of concept. Populous is an architectural firm. They design, as you can see there, they design stadiums and all kinds of things like that. They've taken their proof of concept delivery time from what was measured in months down to only 4 weeks in time by having virtualization available. Being able to very quickly and very dynamically collaborate with each other and share information and being able to remotely access this data, it just makes their workflows much, much quicker and much more efficient. And when we talk about efficiencies, if we talk about Bell Helicopters, subsidiary of Textron, they're seeing overall performance in a workstation for the same workload being 30 to 50% faster, because they can take advantage of the virtualization. They can have users utilizing other people's resources, or that big pool of resource that isn't constantly being used. And if you remember back when I was saying about a customer I spoke with yesterday whose GPU resources are idle for 70% of the time, you make that available to a wider pool of people, or you make more power available to the same group of people without having to potentially invest any more money, and you get you get these much greater benefits.
And I know these guys as well, Jason. What I also see, one of the reasons for performance benefit is that the data and the execution is closer to each other. So the data stores with all the content or the databases are close to the virtual workstation, like with 10 gig Ethernet as an example. And with that, the performance boost is phenomenal as well.
Yeah, if it only takes 2 minutes to open a file versus 20 minutes where you're waiting for it to download before, everybody benefits. People can just work quicker, you don't get distracted, and you're in the zone of working more efficiently.
Yep.
So if we talk about the grid platform itself, we've got it's broken down into 3 parts basically: the hardware itself, the software that runs on the hardware, the grid software, and then the support updates and maintenance components on there, which are basically allow you to make sure that everything is up to date when a new version is released, and also when there's a problem with it, you pick up the phone and you speak directly to NVIDIA. And across the board there, you'll see the various software solutions that will take advantage of it. Obviously, that's not an explicit list. There are many, many more. If you look at how we've innovated over time, and this is one of the reasons why we shifted last year to a software model, is that in 2015, when we shifted to the software model, we increased the worked on the user experience. We delivered Linux virtual desktops with vGPU. We increased the scalability to 16:1, and we increased the performance that we could deliver in the hardware as well. Early in 2016, we made 4K displays ubiquitous. So now anyone with a 1 gigabyte Quadro profile and upwards can have multiple 4K displays, and also introducing that protocol acceleration that we've talked about earlier, which gives that scalability. Virtual applications, a special edition which is specifically focused for use cases like Citrix XenApp or VMware's RDSH, where you want acceleration, but you don't need a full virtual desktop for those users. How do we deliver it? Now you can take advantage of Virtual Apps Edition and deliver that out there. And as you'll see going over time, you can see the plan of where we're going to go further. Greater than 16 users per virtual GPU, better provisioning and management, dynamic migration, service provider licensing, and service provider technology for virtual GPU as well. So this is, you can see, the trends and the direction that we're looking to move in as we move forward. I've mentioned these three. I'm going to move quickly because I'm conscious of the time. So we've got these three tiers of virtual applications: Citrix NetApp, RDSH, virtual PC, your general desktop user. So this is kind of myself and Ruben and those people that don't need those fully high-powered 3D graphic workloads. And then the Grid Virtual Workstation Edition. So that's the one that delivers all of the performance for those users which are the most demanding out there. There's a Grid hardware family. The Keplers, the K1 and the K2 were the cars that we released 3 years ago. And as you can see, we've moved up to the Tesla M6 and the M60 based on Maxwell architecture. Maxwell is not, a direct one-to-one replacement for Kepler. It's actually a dramatic boost in performance and power over those Kepler GPUs. So although you might see a similar count of cores there, what you actually don't see is that each of those GPU cores is dramatically more performant than the previous generation. And things like we talked about H.264 earlier on, the ability to go where we've gone from the K2 from 6 encoded streams in H.264 to 36 on the M60. So a 6-fold increase in performance and power that we've got there, and a doubling the user density that's available to us. I'm going to move over to software licensing because you can either buy it as a permanent license, a perpetual license I should say, or as a subscription offering. When it comes to scalability, there are a number of scalability guides there as well. And now we've moved on. Apologies for running quickly through that, but we're moving on to this poll now. So which hypervisors are you using today for virtual workspace?
Interesting. We'll
There's some really interesting results coming up there at the moment, yeah.
Just wait a couple of seconds. Although, well, we have 10 minutes left for my segment on Atlantis, which is fine, and then we'll just open up for QA, and probably we'll run like 5 minutes, 6 minutes late with all the questions, but that's fine. I see that the audience view, the attendance rate is really high, so people are really interested in what we say and the content itself. So 21% is using Citrix N server. Wow, more than half of the people are using VMware ESX. 40% is Hyper-V, 3% KVM, 10% other, which is pretty high.
Oh.
Interesting one. We'll see if we can follow up on a couple of these. If I'm interested in who answered other, what other means. Could be Zen as an example. I imagine it could be Zen, or maybe like in Red Hat, or maybe an Oracle as well. Could be an option as well. But the majority is vSphere, is ESXi. 20% is Zen server. This makes sense. I've done a couple of servers myself in the past, and this is what I see as well. vSphere first, Zen, Citrix Zen server second, Hyper-V third, and especially on the GPU side, it's not so strong today. It will become a little bit stronger in Server 2016, but yeah, Citrix and VMware are dominating this space as well.
Yeah. I have to say, I'm seeing a lot more interest this year in Hyper-V, and I think it's because of what's coming in 2016.
Yeah, yeah. Different topic. We can talk about.
Yeah, that's one for another day.
Let's move on. What Atlantis is doing in the in this space to solve the challenges we addressed earlier. I think we are really in an awesome position, in a sweet spot position. There's clear demand for all flash. There's clear demand for performance. There's also clear demand for simple. And hyperconvergence is the answer of make it simple. And there's also clear demand for cloud and leveraging cloud from a cost and flexible perspective. And we are in the middle of these three great developments. Developments of all flash, developments of hyperconvergence, and connecting on-premises data center and from a storage perspective, on-premises storage to clouds, not only from a backup and archive perspective, but also for other type of workloads. You will see interesting solutions in the near future in that space. So delivering all flash using hyperconvergence from an appliance and software perspective is what Atlantis is doing today. Virtual workspace within Atlantis, we have deployed over 1 million seats, and so we know this space. Our starting point, our history is in virtual workspace, and a couple of years ago we added a data center to the type of workloads we can handle as well. So it's not only VDI or service computing, but it's like full stretch cluster support, DR, replication, vFlow integration, all the things you need in an enterprise storage and a data center solution is part of that. We are a leader in the hyper-converged desktop virtualizations space. If we look at the numbers, and Project VRC is one of the sources here. It's doubling in the year-over-year growth hyper-converged market space in desktop virtualization. So we are really in great shape in the virtual workspace space. As a company, our intellectual property is software-defined storage. That's where our IP is, and we deliver whole flash performance in the Atlantis USX context. Atlantis USX is our software, which can be deployed on Zen server or vSphere as an example, and creates an distributed storage platform as one of the examples. We can also use the same software and use it in Atlantis Hyperscale, which is a hyper-converged appliance, delivering all flash performance for 50 to 90% lower cost than traditional 3-tier type of solution from like an HP or NetApp or EMC as an example. Freedom of choice can be different vendors, different brands, HP, Dell, Supermicro, Lenovo, Cisco as an example. Freedom of choice, Zen server, vSphere as an example. And modular scalability, both software and appliances are key assets in both Atlantis USX and Atlantis Hyperscale. I know for sure that some people in the audience know Atlantis from Elio. Elio was the first software product we launched a couple of years ago. And Atlantis USX is the call it successor of Elio. So when you're using Elio or when you know Elio, think about USX on USX is Elio on steroids, adding a lot of data services to the software platform. When we look at what we do, we pull and abstract storage, which can be SAN or NAS. We can optimize, we can increase performance from your current SAN or NAS environment. We can increase capacity from your current SAN and NAS environment as well. We can leverage local storage, spinning drives, SSD, PCIe flash, memory, and create a storage platform for that. When you look at the compute layer, adding software on top of the compute layer, and adding the data services, data reduction services, I/O acceleration, data mobility services, data management services on top of that. These are the core assets for us. And data, as an example, data reduction, so deduplication not only from a capacity perspective but also from a performance perspective. Data reduction is and deduplication, compression are core assets in the Atlantis stack. Just one simple example about inline deduplication. So we use in-memory, inline deduplication to improve I/O performance and to increase capacity as well. It happens inline on host. It's not a post process. We don't need expensive or more expensive flash to handle these type of things as others do, and it's inline. It happens on the host itself. It has no negative impact on storage performance, and actually it's the opposite. If you're interested in how things are happening under the covers, how we handle writes, how we do reads, how do we handle unique writes, all these type of things, I'm happy to share under the cover content. Send me an email, Ruben at atlantiscomputing.com. I'm happy to share a white paper and videos to explain how things work, which is really unique in this space. And it runs at CPU and RAM speed, and it's fully software defined. It's software, it's an OVF as an example, running a VM running on Zen server and vSphere. And all our IP is in that VM, and we create a distributed storage platform, or can create a distributed storage platform on top of that. So why Atlantis? Well, it's best of class user experience, and as I explained earlier, user experience is king for VDI and Workspace. It's all flash performance, sometimes leveraging all flash or leveraging memory, It's all flash performance for Workspace and data center. Of course, in Workspace you always have your data center workloads as well. The storage for your designer files or home directories or group directories or other information systems. We optimize current SAN and NAS. We can create a hyperconverged platform leveraging local storage and create a distributed storage platform for that and extend your storage as well, which is unique. Quite often you see that other hyperconverged vendors are just focused on local storage and not leveraging current storage. A lot of vendors, a lot of customers already have SAN and NAS investments and have challenges from a performance and capacity perspective. By adding our intelligent software on top of that is optimizing your current storage from both a performance and capacity perspective. And when the software is, when the SAN or NAS is due, you can use hyperconvergence using your local storage and create a storage and scale out storage platform for that. And use the same software in that scenario. Freedom of choice, so software-defined storage or appliances, so Atlantis USX or appliances. They're both great use cases for software-defined. Software-defined can be applied to blades, can be applied to cartridges, can be applied to rack mount servers. Maybe you have a specific CPU need, as we mentioned earlier in GPU. CPU is an interesting element in that. So maybe you need lower cores and high clock speed. Or maybe you need more cores and lower clock speed. By adding software-defined storage on your hardware platform, you can benefit from that. Freedom of choice, Zen server. We are the only vendor in this space who supports Zen server from a software-defined storage perspective, and VMware vSphere. And programmable infrastructure, I mentioned that earlier, is a key asset as well. So everything we do from a management perspective is done via REST API. Of course, we have our UI, and that UI is also using REST API. And with REST API, you can use automation and orchestration and self-service as a core asset in the infrastructure. I wrote down a couple of joint customers. When I look back in the last 3, 4, 5 weeks, when I speak with customers and partners, which is obvious part of my job, and it's a great part of the job. I think higher education is what I wrote down. I see a lot of movement and demand in higher education, delivering both desktop, remote application, and workstation type of applications to remote users, which can be in Asia as well, or even in Africa or Southern Europe, as an example. Manufacturing, Jason mentioned one of the interesting customers designing quite often workstation type of workload. Intellectual property and DR are core assets. Local government, as an example, in the Benelux last week, I had an interesting conversation with them. They use, in essence, just information workers and knowledge worker type of applications, so desktop and remote application, but they leverage, they use NVIDIA GPU and Atlantis technology to bring these type of applications to any user in the organization and working from home as an example.
Yeah, that's right. And I think one of the things to remember is that, particularly you've just mentioned higher education, is that all of the applications that are being used in commercial use cases, so whether that be geoscience, whether that be architectural design or mechanical engineering, they're also all being used in universities and colleges to teach the people that are going to become the next designer, the next geoscientist, the next geologist or whatever. So, there's a huge crossover there.
Yeah, you see, like trimming down office space or trimming down space in education, as example. The students have their own laptops, so using bring your own device type of scenarios is helpful. Protecting IP, especially in the designer space, is what I see quite often as well. Yeah, there's a ton of, and it's really great to see more and more demand for GPU and solid state and software-defined technologies as well. It's really a pleasure to be in this space and to see all these developments, and also play an important role as NVIDIA and as Atlantis in this space. I think it's good to finalize this and open and see what kind of questions we have, Jason.
Yeah.
So before we do that, yeah, just to emphasize these two topics. If you want to try NVIDIA, you can use TryGrid, go to this URL. Or when you're interested in a desktop virtualization best practices guide, which will be released soon, you can sign up to be first to receive this best practices guide. You can sign up in atlantiscomputing.com/VDI guide, and I know for sure that this guide is a great asset. More than 200 best practices are part of this guide. GPU, hyperconverged storage, sizing, guest optimization, a ton of great best practices in that guide. And TryGrid is also a great asset to see yourself how things work from your own machine and using virtualization and NVIDIA technology to get some great experience on that side.
Yes. So yes, so we've got a few questions here, and so let's crash through them quickly, given the time that we've got. And as Ruben's put up our contact details there as well, so contact us by email or more publicly over Twitter. You'll always find us engaging there, so you'll get some answers. Anyway, so into the questions. First one, which answers a question from a few people that's come in. Can NVIDIA cards, or actually no, when will Atlantis release a hyperscale product which includes NVIDIA GPU?
Yeah, the question when is always an interesting one, especially when it's recorded and not under NDA, which is in this case the case. So I cannot talk when it is, but I know for sure that it is on our roadmap and it has our attention. So when you're interested in Atlantis and GPU, today is the answer is use USX, which is a great platform to leverage GPU and blade 19-inch rack mount servers or cartridge scenarios. You can use Zen server or vSphere. You can use the CPU you like, which fits best in the application. And the simple answer is somewhere in time you will see more and more. You will see the GPU and hyperscale combined as well. When, I cannot explain that in this non-NDA session, but if you're interested in hyperscale and GPU, please send me an email so I can give some insights to you, Ruben at atlantiscomputing.com, and I'm happy to answer that question in a more one-on-one private scenario.
Cool, thanks Ruben. So there's another one here. Does the NVIDIA Grid vGPU Manager work across VMware, Microsoft, Citrix and Red Hat? That's a really good question actually. So vGPU today is currently available on VMware's vSphere and also Citrix Zen Server. So that's where it's available and supported today. Microsoft, there is in the current release 2012 R2, you have the ability to use the grid cards in conjunction with Microsoft's RemoteFX virtual adapter. So you can take advantage of that with grid technology underneath it. And with Red Hat, we'll support the grid technology in pass-through configuration. So that's the one-to-one relationship there on Red Hat KVM. So it is available across the different platforms, and when of course Microsoft's Server 2016 comes out and is fully GA, you'll have what they're referring to as DDA, or Direct Device Assignment, which is another name for GPU for PCI pass-through. So we'll support the GPUs in that as well, fairly close to general availability. So it's not all vGPU, but you can put GPUs in each one of those platforms.
Yep. A couple of people asked if this presentation will be made available. The answer is yes. The recording and the deck will be sent in a couple of days, I assume, to all you, all the guys who registered. So that's part of that question.
There's one about
was Daniel not listed as one of the speakers? The answer is yes. That's the simple answer. More complex answer is there's family, because of family challenges on Dane's side. He couldn't join this webinar, so Jason and I took care of that, and we handled that. So yeah, unfortunately Dane couldn't attend and couldn't participate because of personal reasons.
Yeah, but we will be very glad to see him back when he's
yes,
when he's back on board.
Yep. Other question: is there a free edition of SDS that we could test in the lab? Yes, there will be a free edition be available soon. If you want to test it like right away, again, send me an email, ruben@atlantiscomputing.com, and happy to support you on that side. Let's see how much time we have. Does NVIDIA Grid work with vMotion yet?
Good question. So, it doesn't work with vMotion today, and nor does it work with ZenMotion on Zen server side either. It is in our development path. It is an item that we are working with both Citrix and VMware for their respective platforms. But again, I can't give you a specifics of when and where, because it's not just bound into our technology, it's also bound into Citrix and VMware as well. But watch this space. We are working, and we're working incredibly hard on getting the solution out there.
Another question, can the Atlantis solution benefit a PVS environment in the same way it can benefit MCS, so provision services, machine creation services? Yeah, probably need a little bit more details to understand what the details are about this question, but what I see in the field is both customers using PVS and MCS and both benefiting from using Atlantis. That's what I see, so that's probably the answer is yes, but maybe there are some more details to understand the details about the question. So Ron, if you are able to send me an email with some details, I'm happy to follow up on that one. Thanks, this is your stroopwafel friend, I'll reach out to soon. Thanks, Eduardo. Let's see, free edition is covered.
That's all of them, isn't it?
Yeah, the other one about medical and PACS, maybe the last one as well.
Oh, yes, right. So PACS is actually quite a difficult area to address, because most of the time a PACS solution is a combination of hardware technology. So it will be a workstation, a display, a monitoring solution, and a whole suite of things that are bundled together by the vendor, as opposed to simply some software to be deployed. So to give the numbers on GPUs in the field, it's quite substantial, but because they are actually built into these pieces of equipment. But I don't have definitive numbers on how many are deployed. Will medical applications benefit from having a GPU? Absolutely. So if you have something that you would normally deploy onto a desktop, for example, that may not be for diagnostic purposes, but is for maybe some other forms of review, maybe patient review or whatever, then absolutely, many of them are graphical applications and quite graphically intensive.
Jason Rooney jumped in with, let's make this the really last question. Can you explain the advantages with GPU and H.264? That's not what you write down, but that's what I think. Encoding and remoting protocols, please.
Sure. So H.264 is a compression standard, and it's a compression standard that you've probably all encountered in one form or another, whether it be watching streaming video and compressed video. Things like Netflix, for example, will be using H.264, and also its later version of H.265. So what it's about is it's about taking visual data and compressing it down into a narrow stream. It's very, very efficient, but it's also incredibly resource intensive. So take, for example, running a 1080p display, full screen changing, you're probably consuming an entire CPU core or virtual CPU in a virtual machine. You will fully consume that entire core just to deliver that display down there. Now, of course, everybody doesn't use full screen, full motion video every day of their life, but you can get a view for the amount of demand it will put onto the CPU. So
what's your relationship with remoting protocols, Jason?
So if you look at both Citrix, VMware's BLAST protocol, BLAST Extreme, HPRGS, Mechdyne, Nice DCV, and several others out there as well, they all take advantage of H.264 for compression to give the best visual quality at high frame rates with low bandwidth. So that's why it's used. It's kind of the best way to get the best user experience, or a very good user experience, down to the end users. So you get low bandwidth, high frame rates, and good visual quality there. Now, of course, this has all been done in the CPU, or has to date all been done in the CPU. And the CPUs aren't designed to do this because they're designed to do the jobs that CPUs do, many, many different things. So it's an incredibly CPU-intensive task. On the GPU, on every GPU since Kepler was released and the Kepler architecture, we have put onto that hardware dedicated componentry for encoding for H.264 and H.265. So there's a piece of silicon that's there which is specifically designed to do H.264 encoding. So by taking it away from the CPU and putting it onto the GPU, you immediately free up in the realms of 20 to 25% of your CPU resources that can be used for other things, whether that's more users or whether that's better user experience and better application performance. And you're putting it into a piece of hardware which is designed, and the software is specifically written to do H.264 encoding. So you get even better efficiencies. So what we see is that we actually see an increase in frame rates. We see a reduction in latency because the processing is all happening in the GPU, straight from the GPU's frame buffer. So that's where it's been rendered and drawn as the display image, then encoded and then sent and compressed and sent out.
Less bandwidth as well.
Yeah, and the bandwidth, we don't see quite as much bandwidth being reduced as on the CPU side. Actually, it falls out around the same. But the visual quality, we're seeing much sharper imagery coming out as well. And also and this is because of the likes of Citrix and VMware can take advantage of features in the development kits which, instead of having to write it into the CPU, they can use the SDKs to do. So we're seeing things like the ability for an image to become sharper over time once it's finished moving, which previously in H.264 type protocols we've not been doing, which is it's just a knock-on benefit that it's better quality, it's lower, it's less demanding on the resources, which means you can put more users and get a better user experience in your environment.
Does it mean that the endpoint itself needs to have a decoder as well?
So many of the endpoints themselves, if you again think that Citrix's HDX Pro, 3D Pro is probably the most prolific H.264 based protocol. It's been around for quite a while, and previously, up to date, maybe up until about the last 6 months or so, all of the decoding has been done in CPU, which has become a bottleneck on the client side. And what we've seen again in the last 6 months or so is Citrix have added in the ability to do hardware decode on the client side. So if it's got the capability to do H.264 decoding, which lots of devices have, many devices, anything, even right down to the Raspberry Pi has the ability to do H.264 decoding, so it can offload there. And what it's done is it's made more capacity, or enabled more endpoints to have a rich user experience and have much better graphical performance than they had done previously. So taking advantage of H.264, hardware encoding, hardware decoding, it means that the user experience and the protocol performance can increase whilst actually reducing the load on both the resources in the virtual machine and also on the endpoint itself.
Awesome. That was a very long answer on a very good question.
I was going to say, that's probably another session on its own that we could do there. In fact, I think we may have one coming up.
Okay, awesome.
We'll look into that and maybe share
Thanks
it.
for asking Rooney, and thanks for answering Jason. With that, let's say thanks. Thanks for attending. Thanks for listening in. So thanks for your time as well, Jason. And yeah, thanks very much, and hopefully see you next time. Bye bye.
Thanks everyone. Bye.